Hello to you all. I'm doing this recording based on the information that I'd given you earlier, where I lost the previous recordings for the first two sessions. So I do this separately and I hope to share it with you. So this course is on advanced quantitative methods of research, and among the other things that we saw were sampling distributions, hypothesis testing, and of course making of statistical inference. So I'm going to start with the sampling distributions because that is what we looked at before I proceed to other area. Now, sample survey methods are the principles and methods that we use in collecting and analyzing data from finite populations. So in this case, what it means that for any area of interest that you want to research on, or if you have something that you want to seek further clarification on and back it up scientifically, then it means that you have to identify the population that exhibits the characteristics you're looking out for in that particular area of research. And then from there you can can identify units that you are going to use in your study. Now what happens here is that you have a population. So you have your target population and you are supposed to collect data from units in this population. Now, because depending on what you are looking at, then you can either use the whole population as it is, and if you use the whole population, then it means that you are conducting a census. So in this regard, we can say that if you are conducting we say that a census is when you use the whole population for your study. So yes, if you are using the entire population for your study, then you are conducting a census. So census, you use the entire population for your study. However, there are scenarios under which you cannot use the whole population as is for your study, and therefore you are compelled to use a fraction of the population. Now, if you use a fraction of this population, then you are now doing what we call a sample survey. So in that particular case, if you are limited in terms of resources and other ideals, then you are allowed to use samples to conduct your research. So if you use samples to conduct your research, then you are conducting a sample survey. So using parts of the population to conduct research. Then you are using samples. So what happens is that you have these sets of population. This is the set that consists of population units. And then in this population, you choose to pick a sample that contains all those characteristics of interest, and then it is this sample that you use in your data analysis. Now, there are various reasons as to why you can use samples for your survey, and the first reason as to why you use the first reason as to why we use samples in our surveys is that it involves reduced costs. So, reasons for sampling. One is that it has reduced costs, and we know that in this particular case, instead of using the resources that, especially financial resources that you have to collect data from each and every element in the population, then if you are to use just a fraction of the population, then the expenditure is bound to be less compared to when you were to conduct a census. So in that particular case, it really helps, especially where you have budget constraints. And remember, the larger the population, the more money you need to be able to collect data from each and every unit in this population. So yes, sampling comes in a way that helps reduce all that hassle. The second reason is that we experience greater speed. And this is due from the fact that we are using part of the population. So if you're using part of the population, the expectation is that data will be collected and summarized more quickly as compared to when you would have conducted a complete count. Now, in this particular case, then it means that based on what you're doing, you expect to get the results quickly. So if you are constrained in terms of time, it's recommended you use samples as your way of collecting data. Another thing is because of accuracy. And in this particular case, because you are using samples to collect your data, then it means that you are going to put more effort in ensuring that your personnel that are going to help you conduct the study are given intensive training on what is required with respect to collection and data analysis, and also because the size of the units is smaller, then it means that even these personnel are going to be more careful in supervision and even the processing of the results. Now, all this will eventually improve on the outcome of your research, and therefore the expectation is that results obtained using sample surveys are of higher accuracy or precision compared to when you conduct a census. Sometimes in the census, you find that maybe even the enumerators, they do not collect data from each and every individual. Not everybody is enumerated, not everybody is enumerated in a census, and it puts a lot of question marks on the credibility of the outcome. Now, another reason is because of the greater scope that we are able to cover using sample surveys. And in this case, it implies that by identifying your target population, and especially if you want to conduct a sample on a larger scale, then, or rather, if you want to conduct a survey on a larger scale, then it means that you can always spread your wings. You can pick a sample from Accra, you can pick a sample from Kumasi, you can pick a sample from Tamale, and so forth. So it gives you the flexibility to be able to reach greater areas, or rather to reach other areas that could provide you information of interest. So those are the four main reasons as to why the use of samples is preferred to a complete census. Now, having understood the reasons as to why we do this, it's important that before you start any survey, then it means that you need to have your objectives well stated. You need to have your objectives clearly stated. Otherwise, without your objectives, then it means that you are bound to experience some form of difficulty. So it's very important that before you begin your survey, you first of all have to clearly define your objectives, because it is these objectives that are going to help you identify your target population. It is your objectives that are going to help you identify ways in which you can select a sample from the population, and how you can even determine the size of the sample. So yes, in this particular case, it's very important that objectives are clear. If the problem is that if your objective is not clear, there is a likelihood that you are going to start conducting your study, and then you'll be stuck because you are not getting what you are expected to get or what you had hoped to get. And the reason as to why that will happen is because the objectives that you had, they were wrong, and they took you to the wrong path. So you have to go back to the drawing board and try to restructure your objectives again before you can proceed. And that is a lot of time wasting. And I think that is most of the times what wastes students' times when they are conducting their research. So please, correct specification of objectives is very important. Now, once you have identified your target population, then you have to select a sample. But we have various ways in which we can select a sample from the target population, and it is all guided by what you intend to achieve. There are two methods of sampling: probability sampling and non-probability sampling. Now, the difference between the two methods is that in probability sampling, we have a guided structure on how you select your sample. There is a laid out mathematical or statistical procedure that can help you identify your sample. So what happens is that for each unit in the population, there is a non-zero probability that that unit is going to be included in the sample. For each unit in the population, there is a non-zero probability of the unit being included in the sample. So with that, then you do realize that there is that structure on how you are going to identify the units that form part of your sample. On the other hand, non-probability sampling does not have those kind of restrictions. Non-probability sampling, it's all guided by preference. It's all guided by things like preference and how easily you can access your population or your sample and so forth. So there's no laid down procedure, or there is no strict methodology on how you should identify your sample. But in probability sampling, it matters a lot. So we are going to start talking about probability sampling before we go to non-probability sampling. Now, in probability sampling, we have various methods of sampling. We have various techniques of sampling. And in one of those techniques of sampling, we have simple random sampling. In one of those techniques, we have simple random sampling. So on probability sampling, we have the first one, which is simple random sampling. And in simple random sampling, what happens is that you have a population of interest that has heterogeneous characteristics, whose units have heterogeneous characteristics. So in this case, we have our population of interest being heterogeneous. So our population of interest is heterogeneous. The population of interest is heterogeneous. Now, from this population of interest, we are supposed to pick a sample. So we have this population. This is the set of population units that are heterogeneous in nature. And then from that, you pick a sample. So in this particular case, let us suppose that x1, x2, all the way up to xn are the population units. Let this be the population units that are heterogeneous in nature. Now, from these population units, we are supposed to identify the sample. So a sample of size small, from this case, because we have capital N units in the population, then we can say that the population size is equal to capital N. Now, from this population size, you need a sample of size small n. So in this particular case, it has to be such that n is less than or equal to capital N. There are scenarios. Now remember, if small n is equal to capital N, then it means you are conducting a census. If small n is equal to capital N, it implies that you are conducting a census. So in this simple random sampling, first of all, as it is for probability sampling methods, probability sampling techniques, here each unit in the population has a non-zero probability of being included in the sample. So once you are able to determine that probability, then it becomes easy for you to identify those samples. Now, there are two ways in which you can select units into the sample. First, you can select units without replacement. So you can select units without replacement. And what this means is that a unit can only appear once and only once. A unit can only be selected once and only once into the sample. So you have the population, you pick a unit, and once you pick it, that is it. That is sampling without replacement. Now, you can also pick your population with replacement, or rather you can select the units with replacement. And in this case, what happens is that you select a unit, make the observation that you want to make, and then take it back into the population. Again, select another one, make the observation, take it back. Now, the drawback with sampling with replacement is that there is a likelihood that you are going to, there is a high likelihood of a unit being selected more than once into the sample. And that means that for some units, there will be some form of replication. For some units, there's going to be some form of replication. And if this happens, then it is bound to affect the accuracy of the results, because one, you have observed a unit at least once. You can select the same unit even up to 5 times or whatever. Now, that means that other units are not, other characteristics or other units are not incorporated into the sample, and therefore the results that you're going to get when you select your sample with replacement are not going to be accurate compared to the ones that you are going to select without replacement. And therefore, because of that, we always, unless there is a compelling reason, we always select our units without replacement. We always select our units without replacement so that we can improve on the accuracy of the results that you had. Now, that is one method, that is one technique of probability sampling, which was simple random sampling. The second technique is stratified random sampling. So for the second one, you have stratified random sampling. And this stratified random sampling is recommended when you want to improve on the accuracy of your results. Now, remember that your target population is heterogeneous in nature. Your target population is heterogeneous in nature, and therefore you may want to improve on the accuracy. Now, remember that if the units in your population are heterogeneous, then you'll be required to pick a very large sample in order to incorporate the most important features into the sample. So the more heterogeneous your population is, the larger the sample that you need to be able to have more reliable outcome. Now, if you find that this population of yours is so heterogeneous that you may end up spending a lot on trying to identify the ideal sample, Then it is advised that you divide your population into subgroups. You divide your population into subgroups that are homogeneous in nature. You divide the population into subgroups that are homogeneous in nature, and then from that particular from those particular subgroups, you can then select your sample of interest. Now, just like in this particular case, this is what we're saying here, that if the your population is so heterogeneous, it implies that you'll need to use large samples to get the correct results. But the other alternative is that you can divide your population into smaller subpopulations that are homogeneous in nature. You divide your population into subpopulations that are homogeneous in nature, and then from there you can collect the data that you want. So this is just a pictorial illustration of that. This is a pictorial illustration of that. So you have a population of n units that are heterogeneous in nature. You have a population of capital N units that are heterogeneous in nature. So what you'll do, you are going to divide your population into smaller subpopulations or subgroups. You divide them into smaller subgroups that are now homogeneous in nature. So what happens here, homogeneity is such that it is not the same for all stratas. So you'll find that for stratum 1, the units have a common feature that is different from that which is in units in stratum 2. So characteristic-wise, stratum 1 is different from stratum 2, which will in turn be different from stratum 3, stratum 4, and so forth. So each of these, supposing that you have H stratus, then these H stratas are going to be distinct in terms of characteristic. So they are within homogeneous. The stratas are within homogeneous but between heterogeneous. By heterogeneous here, I mean that strata 1 and strata 10 totally different. Strata 2, strata 3 totally different. Strata 1, stratum 2 totally different, and so forth. Now, this classification is such that the size of stratum 1, if you sum up all the sizes of the strata, that is, if you take the size of stratum 1 plus the size of stratum 2 plus the size of stratum 3 and so on for all stratas, it must equal the original population size. So it must equal the original population size that we are having up there. Now, from these stratas, we now select sample units. From these stratas, we now select sample units from our stratum population. So from stratum 1, you select sample 1 of small n1 units. From stratum 2, you select sample 2 of small n2 units, and so forth up to stratum H, where you are going to select sample H of NH units. Now, remember, there is this target sample size that you have. Let the sample size be N. The sample size be N. This target sample size has to be realized when you are selecting these samples. The target sample size has to be realized when you are selecting these samples. So it means that if you take the sample size of sample 1 plus the sample size of sample 2 plus the sample size of sample N, it must give you the target sample size that you had in mind. It must give you the target sample size that you had in mind. So yes, that is how you can, first of all, divide your heterogeneous population into subpopulations, and then from those subpopulations, you now select samples that you are going to use in your data collection. So it means that now here, once you have the samples, each and every unit in each sample has to be enumerated or observed. Each and every unit in the sample has to be observed. So sample 1, all units will be observed. Sample 2, all units will be observed, all the way to sample H, where all units are also going to be observed. So that is how you classify your population before you can proceed to conduct your census. So this is the procedure that you can use. 1, divide your population of n units into H strata, and for each strata you have a size. Each stratum is of size ni. So n1, the size of stratum 1, n2, the size of stratum 2, n3, size of stratum 3, and so forth. So these stratum sizes will be constructed in a manner that they must make up the whole population size. The sum of all stratum sizes, as you can see here, the sum of all stratum sizes must make up the whole population size. Now from this, you then now select, from each stratum, you now select samples of size ni. You select samples of size ni from each and every sample. And remember, these samples you select, they must give you your desired sample size. That is what we do in stratified sampling. The other method of sampling is systematic sampling. And in systematic sampling, here, first of all, you have to arrange data in some chronological order. For systematic sampling, you have to arrange your population in some chronological order. This chronological order could be due to maybe smallest to largest, in all those sizes. So you arrange them in the order, and then you can identify how you want to start selecting your sample. So for this particular method, so for systematic sampling, here your population units have to be arranged in some chronological order. Now, systematic sampling has its advantages. Systematic sampling has its advantages over other methods of sampling. Reason being, it enables us to capture even the rarest of the events. Remember here, you are selecting your units from a population that has already been arranged in some chronological order. So it allows you to capture the extreme characteristics. It allows you to capture the extreme characteristics that could be present in that particular population. Now, because with this method you are able to capture the most extreme characteristics, then this method becomes better compared to simple random sampling. Remember, in simple random sampling, what happens is that you randomly select units. Into the sample. So it means that there's a likelihood that you are going to miss some very important units. There's a likelihood that you'll miss out on units that are going to give you some very important observations, like the kind of extreme observations. So systematic sampling comes into play very well. Now, in systematic sampling, we have a procedure that we use. First of all, you have a population of size P, or rather you have a population P of size N, and you are interested in a sample of small size N. So once you have this, list all the population units in some chronological order. This chronological order is going to be determined by what you intend to achieve. So suppose the chronological order is like from smallest to largest. Then once you have arranged your data, your population units in that order of small to largest, then you can now start doing using systematic sampling. But the first important thing that you have to define is this sampling fraction. This sampling fraction is going to help you know the number of jumps you are going to make. So first of all, we'll define a sampling fraction f. For systematic sampling, we are going to define a sampling fraction f to be equal to the sample size divided by the population size. Now this is what is going to help you identify your jump, because now in this particular case we now have this. If we take the inverse, of f, for example, if we take the inverse of f, from this, if we take the inverse of f, it will be n over small n. Now this inverse of f is what you are going to use to determine the jump. So we'll define the jump that you'll use. It's important that in systematic sampling you identify the jump that you are going to use. The jump that you are going to use, let's say the jump g that you're going to use is going to be defined as the inverse of the sampling fraction, n over n. So after each gth element, you pick a unit into your sample. After each gth unit, you pick a unit into your sample. So that is what we have here. This is the jump. So you have your jump. You have your jump here. This is the jump. And then identify a random start. You randomly identify a start, and then from there you pick each gth element. After each gth element, you pick a unit into your sample. After each gth elements, you pick your unit into the sample. So here is an example. If we consider a population of size 8,500, from which we draw a sample of size 100, then we can calculate our sampling fraction as the sample size divided by the population size, so that we have our sampling fraction to be 1 over 85. And now, once we have our sampling fraction, we can get the jump. That is, G is, remember, G is the inverse of F, so it is going to be 85. The inverse of 1 over 85 is 85. So that is going to be your G. And then from there, once you identify a random start, you can proceed to pick a unit into your sample. Yeah, so that is just how you can calculate the jump. For systematic sampling, it's important to know how to calculate the jump that will be required for you to identify the next unit in your sample. So generally, this is just a general structure. Now, in this particular case, we are using the population of 8,500 units, and our random start, you must identify a random start. A random start could be the first element, the second element, third element, or anything that you wish. And then from that random start, now you can continue to, so the first unit into your sample, will be the random start 17. This is the random start that we just identified. It's random. The second unit will be determined in this manner. So after the 17, the first random is 85, or rather the first unit is 17, and our jump is 85. So the next unit that we are going to pick is going to be after 85 units, which is 102. The second unit will be the 102 unit in the population. The third element will be 102 plus 85, 187 units in the population will be your second sample, your third sample unit, and so forth. So you'll do so all the way until you get your 100 sample units. The 100 sample unit will be given by 8,432. So you realize that at the end, once you are able to apply this method through all the population units, you'll end up having the sample size that you are interested in. And this is how you can, this is just an example of how you can select a sample using systematic sampling. Remember, you need to identify the jump G and also the random start. The random start doesn't necessarily have to be 17. It can be the first unit. So you can say that your random start S is equal to 1. If S is equal to 1, then it means the first unit in the population gets into the sample. The next unit will be 1 plus 17, which is 18. So the 18th unit becomes your second in the sample, and so forth. So please note that this is how you can use systematic sampling to make to identify your ideal sample. Remember, like I told you, because we arrange our population units in a chronological order, then it allows us to capture the rarest or even extreme of the events, and therefore systematic sampling gives us better results compared to simple random sampling. The other method is cluster sampling. The other technique, probability sampling technique, is cluster sampling. And in cluster sampling, you have a very large population and then you divide it into groups or clusters. And then now from these groups or clusters, you can pick a random sample that you can use to that you are going to use to make your observations. Now, in cluster sampling, it's almost the same as, in principle, is the same as stratified sampling. The difference is how you identify your samples. Now, in cluster sampling, again, we have heterogeneous population. And then in this heterogeneous population, instead of dividing the population into homogeneous subgroups, we now just identify our subgroups are going to be still heterogeneous. So from these heterogeneous subgroups, we now collect data. Now please note that the difference between cluster sampling and stratified random sampling. In stratified random sampling, we have a heterogeneous population that we divide into homogeneous subgroups. Cluster sampling is the opposite. We have the heterogeneous population, which will still divide into heterogeneous subgroups. And then from there, we we are able to enumerate. So here is an illustration of cluster sampling. So in here I describe circumstances under which cluster sampling can be used. So in this case, these are the scenarios under which cluster sampling can be used, and here I have a procedure. So you have your heterogeneous population, and then you divide the whole heterogeneous population into clusters, and then we treat the clusters as our sampling units. It is the clusters we treat as sampling units. Remember, in stratified sampling, we were treating population units as sampling units. Here, we are treating clusters as sampling units. So we are going to choose random clusters, a sample of clusters, using a procedure that you may want. So you randomly choose clusters, and then once you identify your sample of clusters, you have to enumerate, or you have to make observation for each and every unit in that cluster. That is what we are having here. Carry out a complete enumeration of the selected clusters. So collect all the information on all units available in the clusters that you selected. So here is a pictorial presentation of cluster sampling. So you have a cluster, a population. This is the population. And in this population that is heterogeneous, you divide it into clusters. So you have n clusters. You have n clusters. So you have those clusters. Now, this population of n clusters is what is going to be your sampling units. This population of clusters is what is going to be your sampling units. From these sampling units, you now randomly identify clusters that you are going to use in your survey. So our population now here is not having n units. Our population of clusters is n clusters. We have a population of n clusters from which we draw a sample of small n clusters. We have a sample of small n clusters. And once you have the sample of small n clusters, you have to observe each and every unit in these clusters. You have to observe each and every unit in these clusters. The best illustration of cluster sampling is we consider the Republic of Ghana as our population. Let us consider our Republic of Ghana as the target population, and this Republic of Ghana is divided into regions, 16 of them. This Republic of Ghana is divided into 16 regions. Now, those 16 regions become your clusters. The 16 regions become your clusters. That means that your population has 16 clusters. For Ghana, your population has 16 clusters. Greater Accra, Oti, Ashanti region, Savannah region, Northeastern, all those regions, they are your clusters. So in this case, your population is in form of clusters, regions. Now, from these regions now, these 16 regions, you select a sample of clusters. You select a sample of small n clusters. So you can randomly select. Maybe you are only you are only now trying to reduce your forecast to 5 regions. Maybe you are interested in reducing your forecast to 5 regions. So you can identify using a desired procedure. You can identify the sample clusters. So you can say Greater Accra is part of it. The Greater Accra is part of your regions: Western region, Savannah region, OT region, Northeastern region, all those. So you identify your small n clusters, and once you identify those, each and every unit in those clusters has to be enumerated. So if you picked Ashanti region as one of the sample clusters, you observe each and every unit in Ashanti. If you identified the Volta region as part of your clusters, sample clusters, each and every unit in the Volta region has to be observed. So you have this, each and every unit has to be observed, and then from there you can conduct your data analysis once you have all the information that you need. So please know how to distinguish between stratified sampling and cluster sampling. And I think you can see the difference. In stratified sampling, we were considering population units. In cluster sampling, we are considering population clusters. In stratified sampling, we are considering sample units. In cluster sampling, we are considering sample clusters. And then for cluster sampling, each and every unit in the sample cluster has to be enumerated. But for stratified sampling, you saw that for stratified sampling, here is stratified sampling. For stratified sampling, once you have your stratas, your subgroups, you draw a sample. Subgroup, draw a sample. Subgroup, draw a sample. And then observe all the units in this sample. So this is the form of stratified sampling, and this is the form of cluster sampling. They are different. Please know how to distinguish. Next, you have multi-stage sampling. Now, multi-stage sampling is advanced cluster sampling. It's part of cluster sampling. So you divide your large population into stages. And then you now, once you are able to identify the stages that you are going to use, you can combine either stratified sampling or cluster sampling, or whichever sampling, to try and collect information from your unit. So yes, now in an example of multi-stage sampling is, let's say, a scenario of malaria prevalence. You have malaria prevalence. So you have Ghana as a region. You divide it into groups, so regions. You divide it into regions. And because you are interested in malaria prevalence, maybe you are interested in the number of hospital admissions. You are interested in the number of hospital admissions. So you are going to divide your country into regions, and then in the regions you have to identify hospitals. Identify the hospitals in those regions. Maybe they are referral hospitals in the regions. Identify those hospitals in the regions. Now, in those hospitals, they are into departments or sections, and malaria is most likely to fall into the case of tropical and infectious diseases. So you specifically, from the hospital as a whole, you specifically go to the Department of Tropical and Infectious Diseases. That is where you want to get data on malaria and malaria prevalence and so forth. So yes, you do realize that we are moving from the national level and coming down to the hospitals. We are coming down to the smallest units in the hospitals, which could be departments that could be dealing with what you are interested in, and that is what we call multi-stage sampling. So those are the main probability sampling techniques. Next is non-probability sampling. And like I said, in this non-probability sampling, there is no guiding rule. There is no guiding rule on what should be looked at. Like there's no strict definition of the structures that you have to follow to identify your sample. So one of the probability sampling techniques is quarter sampling, and in quarter sampling, the participants of your study are chosen on the basis of some predetermined characteristics. So maybe you have some predetermined characteristics of your target, of your participants. Once you are able to identify these predetermined characteristics, then you can identify your participants who are going to form part of your sample that you are going to use in your data collection. The second one is snowball sampling. Now this snowball sampling is used in a case where we are having a population with peculiar characteristics. And it is very difficult to get participants into your study. It's very difficult to get participants into your study. So you'll have to employ a technique where you first of all identify one person who will lead you to another person, who will in turn lead you to another person, and so forth. So that is why it has a snowball effect. As the ball rolls on snow, it keeps collecting ice and so forth. So yes, and here the target population has those peculiar characteristics that maybe some people are afraid to speak of. Things like witchcraft. Witchcraft is something that is bemoaned upon in society. So someone cannot just come openly and say that I'm a witch. No, but you may be interested in trying to understand their perceived social construction and how they think society views them and so forth. So you'll need to use tactics to get participants into your study, and those tactics could involve tipping them money. You tip them money so that they can lead you to the next person, and so forth and so forth. So yeah, the snowball effect is there. Another method is convenience sampling, and here you sample based on how easy it is to access participants of your study. So if you are interested in understanding the market's penetration of a particular product, the best place to go is to the market and randomly ask people what they think about that product and so forth. So that's what it is, convenience sampling. It's all about convenience. The next one is purposive sampling. Now, for purposive sampling here, you already know what you want, and you know the particular region where you can get participants of your study. So you don't waste even time trying to convince whatever. You just go into that particular section and get participants into your study. So if you know that the people who are ideal for my study are from this particular area, you just go to that particular area and identify your participants into your study. Now, the problem with non-probability sampling methods is that there is a very high likelihood of your participants not being a representative of the population. There is a very high likelihood of your representatives of your sampling, of your participants not being a representative of the population. And remember, in surveys, it's important that your samples are a good depiction of the true population. Now, for non-probability sampling, because of the way in which we identify participants or how we identify sample units, then it becomes very difficult to achieve that particular objective of representativeness. It becomes very difficult, and that is likely to affect the outcome of this. Now, another thing is that because there is no laid down procedure on how you can identify your sampling units, there's a likelihood that a surveyor can use their own bias. They can use their own, maybe because in this particular case it's all about subjectivity of the surveyor. So the surveyor is likely to be biased on where to get information from. And if you're biased of where you get information from, then you cannot purport to have it as a representation of the entire population. For instance, maybe you have a funded study on access to education. Maybe you have a funded study on access to education for children in Ghana, and you decide that you are only going to focus in regions like Accra region. In particular, let's talk about the metropolis. You decide that you are going to the Accra metropolis. Now, it is obvious that because Accra is the capital city, it has concentration of facilities such as hospitals, schools, recreational facilities. They are open to opportunities that the residents there have opportunities that can provide an income for them, and you decide to focus on that particular region as your area of study. Remember, there are regions where children, they don't even have classrooms, they don't even have teachers, they don't even have food. All the kids in those regions, they're only concerned about seeing tomorrow, but how they see it, they don't know how they're going to see it. So in that particular case, you do realize that the outcome of that survey is not going to be a true depiction, and it will be very wrong to use that kind of survey to make inference for the entire population. And remember, your outcomes are going to be used in policy making. So you can imagine if someone just conducts the survey here in Accra, where everything is available, and then goes to say that in Ghana, children can easily access hospitals, they can easily access schools with well-funded facilities, well-paid teachers, utilities like electricity and water are easily available. When we know in the real sense, there are people elsewhere who do not have access to those kind of amenities. So yes, non-probability sampling is bound to introduce that type of bias into the survey, and that will mean that it interferes with the accuracy of the results that you are going to get. So here is the strength and weakness of each method of sampling, each technique of sampling, and we've seen each has its pros and cons, but depending on what you want, you have to correctly identify the technique of sampling that you are going to use, and then identify the sample from which you are going to collect the information that you want. Now, I'll stop at this point, and then the next recording will be on sampling errors and how to identify sample sizes. So please, those are the main methods of sampling, and for each method of sampling there is a technique. Now remember, your objectives will determine the technique you use. Not all surveys or not all forms of research will require you to use probability sampling. In fact, if you go to areas like social sciences, sometimes non-probability sampling is commonly used there. Non-probability sampling is commonly used there. It's all about what you want to achieve and how you want to achieve it. That way you'll be able to identify the correct methods of sampling, the correct technique of sampling, and also know how you can select elements to form part of your samples for the analysis. So I stop there. Until next time. Thank you.